So continuing the 2014 physics challenge work through. So we're on to question 5. It's the voltage current graph for a filament light bulb is shown below. So we've got current voltage, and what we can see here is that for a certain amount increase in voltage, we get the same increase in current. So to begin with, at these lower values for voltage and lower values for current, they look more or less proportional, and we'd say that is obeying Ohm's law. And that's because the temperature isn't changing. But then as it gets, as the voltage increases and the current increases, the current heats the filament gets hotter. So we actually get a less of an increase in the current for the same change in voltage. So if you're getting less of an increase in current for the same change in voltage, that must be due to the fact that the resistance is increasing. So up here, we've got higher resistance as temperature increases, and it's no longer ohmic. Okay, so as we get up here, and it's the same in the other direction, so that's what's going on. So then we have the graph has this shape because resistance to the filament increases as the current increases. Well, resistance to the filament does increase as the current increases because the temperature is increasing. Let's just check the others. Resistance decreases, current increases. No, that doesn't make sense. Filament has higher resistance than the connecting wires, probably. Filament has lower resistance than connecting wires, probably not. But we have no way of really telling that because it's just telling us about the filament bulb and then none of the above, and doesn't really apply. So the answer to that one is A. Okay, question 6. Looks like a refraction question. Refracted as a light ray is refracted as it crosses from air into glass as shown. When the angle of incidence is increased to 80 degrees, angle of refraction will be approximately what? So the angle of incidence is this angle, and so we have this going this way. So we have the ray actually going in at a much larger angle. Okay, I haven't quite doubled it, but something like that, you get the idea. And then the angle of refraction will be larger, so it won't be as small as 28 degrees, but it will definitely be smaller than 80 degrees, so it'll be somewhere in there. Okay, so we'll have that. So something along those lines, of which I can see that there are 3 possibilities that could be right out of those. I don't know, I'd need to actually calculate it. So I'm given these 2 values, so I can calculate the refractive index of this, and then I can work it out from the refractive index. So a couple of steps, bit involved. I don't need to worry about total internal reflection in this case because we're going from air to glass. If we were going from glass to air, I might need to worry about that. So n is sine I over sine r. So the sine of 40 divided by the sine of 28 should give me the refractive index. So we've got the sine of 40 divided by the sine of 28. And that should give us the refractive index. So the sine of 40, get this correct this time, divided by the sine of 28 will give us a value greater than 1. So I hadn't put it in my calculator correctly, and I knew that was wrong because I got a value of less than 1. So I got 1.37. I might leave it in my calculation as 1.369170, all that stuff. So then when I move to the next one, this time I can rearrange this. So I want the value for r. So I get that sine of r equals the sine of I over n. And I've just calculated n. This time the sine of I is 80 over 1.369, and all that other stuff that I'm going to leave in my calculator. So I will do the reciprocal of that value multiplied by the sine of 80 will give me this value. So the sine of r is 0.71927 and all this other stuff, and then I need to find the inverse sine of that value to get the angle. And I get that it's 45.99 and some other stuff degrees, which is closest to answer B.